Hello everyone, welcome to the online video tutorial series of Computer Network subject. I am Nishan Sheikh, Assistant Professor in IT/ICT Department of NJ Institute of Engineering and Technology. So in previous video of Data Link Layer, unit number 5, I already covered major topics about introduction, services provided by Data Link Layer, error correction and detection algorithms, and also briefly introduced the multiple access protocol. Now this is the last video of our Data Link Layer series. So in this video, I will cover about different lengths technology that will be used by our data link layer and also the concept of bit stuffing and byte stuffing. So let's start our today's topic with the starting of our data link layer Ethernet switches. So when we are talking about these switches, so you heard about that routers, switches. These devices are used for packet transfer over the network. So Ethernet switches are basically used at our data link layer, whereas we are using routers at the network layer, that is our third layer. So what are the basic differences between them? Let's understand how the Ethernet switches is working. So when we are talking about Ethernet switch, it is a pluggable. When we want to transfer the data, that particular Ethernet switch is self-learner, self-configure, and our packet is transferred to the next particular destination using store and forward mechanism. So this is a data link layer devices. It in that particular switch, when any packet is received at that switch, it examines what is that MAC address of the particular file, and then it selectively forward to this one or more outgoing links of that particular switch. For that, it use also the MAC layers. That MAC layers is configuration of our data link layer, and for MAC protocol it uses CSMA/CD, that is used for collision avoidance and detection. So when we are talking about the transparency of our Ethernet switching, then it is a transparent. That means if our particular source is sending the data, then it is totally unaware about the background process, but indirectly it knows that my data will be received to the destination with the help of this particular switch. So let's understand in detail how our packets will be sent when our number of hosts are connected with single switch. So let's understand. We have A dash, B dash, C dash. 6 machines are there. For connection of that 6 machine, we are using in the center, there is one central switch, and for that dedicatedly 1, 2, 3, 4, 5, 6 are our interface. So hosts are, each and every host are dedicated connection path, and each and every data which we are sent by this particular devices, what happens, that data is sent to this particular switch. That switches are buffer that packets and examine for which particular destination that source is giving the data, and then the further task will be forwarded. So if we want to send the data A to A dash, then B to B dash, then we can simultaneously send here, because switch can simultaneously transmit more than one packets. So if in my DPR I have a question that how does the switch A dash reachable via interface? How does we can reach to B dash? Initially, if our source and source are not aware about this route, how my data is going to the destination. So for that, our switch device is maintained switch table. Using that switch table, that all these entries of the devices of the network will be maintained. But when the first time request is coming there, then for that each and every time the switching table is updated. The switching table is just look like our routing table, that will be briefly discussed in our network layer scenario. So we can say that our switch is a self-learner. First time when it is requested, then it will revise all the data when the same request will be performed by our source. So for example, if A wants to send the data, destination is A dash, then it will send the request to our particular switch, and switch will be perform the task how it will be sent to our next data. For that, we already discussed one switching table is maintained. This switching table having the field of MAC address, interface, and time to live field here. So initially this table is empty. example, our data is source is A and destination is A dash, but request is coming from our which host, that is A. So first MAC address is maintained here for A. Which interface will be used here? The interface is one here, and time to live is all about how the data is maintained for which time period. For that time period, the data will be maintained here. After that, this data will be erased from our switching table. So each and every time when the request is coming in and coming out, this our switching table is updated, and with the help of this switch table, our data will be generated and maintained throughout the session of packet transferring from source to destination. For that, this algorithm step will be followed. So this is the very basic simple. When the frame received at any switch, so first step is record incoming links from which interface is data is sent, examine the MAC address. Then index switch table is used, that MAC address for future reference. For what that particular data item our source is requested, it search in that MAC switching table. If entry is founded, then definitely it will give the response from that particular table, and our data will be sent. But if that particular data item is not received, then it will not give that data item directly. Then what happens? It floods. Floods means it tells all other participants of that particular network that who is this, for what my incoming device is requested. So flooding is a technique using that particular switch is requesting to all other devices for which MAC address my data item is requested. In the response, it will generate instead of that, it will generate a single cast, that is your unicast message. And after the receiving that, it will maintain the particular entry table, and from that it will give the response. So let's understand all these steps with the help of this example. So our source is A, destination is A dash here. For that, initially our table will be empty. Now when our request is generated, then our request will go through our switch table. At that time, it will update our switch table. MAC address is A right now, our interface is U, and time to live field is our 60. So destination A dash right now, A dash is not maintained here in our switching table. So what happened in next? So the task of our switch is to generate the, or we can say that we have to find the address of A dash. For that, it will use the concept of flooding. So you can see here how the flooding is generated. So except the sender, switching table is generated the flooding mechanism. Now after flooding, you can see that A dash will generate the response, and that data will be maintained in our particular switch table. So this is the selectively send. We can say that it is a selectively send by this particular one link. All other link B dash, C dash, B, C are not generating the output. Only the dedicated machine is generating the particular response. That response will be maintained in our particular switch table, and then from that particular switch table, it generates the output. So this is the all about how our self-learning forwarding mechanism maintained by our Ethernet switch. Now we are moving to our next topic, that is all about VLANs, that is known as a virtual LAN. So when some situation is happening, let's see some situation in big organization, different departments are there. So here computer, electrical, and computer, 3 different departments are here. Now for example, this department, some user moved from computer science to electrical, but he wants that particular switch address is maintained throughout its whole journey. It is changed its location from one department to another department, but it wants to maintain that particular all data item. So how can we manage that? Because physically this machine is connected with computer science switch, but electrical engineering department switch is connected with electrical engineering department switch. But user is moving from one to here. How can we maintain that data from different switch, or we can say that how that switch are interconnected? So virtual LAN is an answer of this type of situation. So for that, it will use different type. From that, we are learning port-based virtual LAN. So port-based virtual LAN is nothing but it is a group of particular port. That group will be maintained by our administrator. So if we have a 16 port of switch, from that 8 ports are maintained by some other group, and another 8 port will be maintained by other group. So we can assign some ports for computer science branch, some port can be managed for our electrical branch. That's why we can say that different department can be managed within the single switch. That is the concept of our virtual LAN. So virtual LAN having the capability that we can separate the group of people using a single Ethernet switch. So this is the basic idea how our department will be used. For that, we already discussed about that a port based virtual LAN will be used, and that particular switch will be maintained by one manageable router, and that router will be maintained by our system administrator. Now the last topic of this unit is all about the stuffing. So let's understand what is stuffing in our data link layer. So when we are transmit the data using the link layer, then first is divided into the frames. So what are the length of these frames? Is it fixed or variable? So when we are talking about the variable length framing, the size of each frame will be transmitted in many different patterns. So pattern, that means in my data will be 1101010 or 101010. So how can we know that my data, from where my data is started, what is the ending of my particular frame? From which point next frame is started, from which point my frame will be ended. So when the data form is same, so how our machine will identify the scope of our frame? For that identification, we will learn two approaches, byte stuffing and bit stuffing. So let's understand this mechanism one by one. So first we will learn about bit stuffing. So bit stuffing is basically used in bit oriented protocols, where the data is in the flow of number of bits. So most of the protocol is using the 8-bit length. That pattern will be 0, then 6 times 1 and then 0 as a flag at the beginning or the ending of each of the frame. So if any protocol is using this approach, when the frame is started of the data frame is started, before that 0, 6 times 1 and 0 is added, and when the data is ended, at the last 0, 6 times 1 and 0 will be added. From that, receiver can identify what is the data, what is the exact one frame is started, and in which place that frame is ended. So in bit stuffing, the problem is there, if a 0 and 5 consecutive successive ones are then how can we identify that is this a particular bit frame or this is my particular data? So for that we are using the concept of flag bit, that is flag bit is additional 0. So let's understand this example. In this example you can see that in our data 3 times 0, then consecutive 6 times 1s are there here. So that will be confusing here. If consecutive more than 5 times 1 is appearing, then it can be considered as a data as well as flag. So for that we are adding one extra 0 bit at the sender side, and the receiver side we will remove that. So at the sender side you can see that after consecutive 6 times 1 we are adding one extra 0 bit. At this place we can maintain this type of data. So in this data we are adding 2 extra bits of 0 bit. At the receiver side it will check if in the after the header, if the after continuous 5 if any 0 is added, then it will be removed here. So in the bit stuffing, this type of complication is solved using the extra 0 bit. Now we are moving to the next mechanism, that is all about the byte stuffing. So if a pattern of the flag bit is presented in the message byte, so when we are talking about the byte stuffing, here all the data are transferred in the form of byte. So here strategy is that the pattern of data and original flag will be same. Then what is the how we are moving to how can we solve this pattern mismatch? For that we are using the concept of byte stuffing, and basically it is used in character oriented programming. So let's understand how it will be solved. So for that we are using the escape bit. In our bit stuffing we are using only single bit because it is a bit oriented protocol. But when we are using the byte stuffing, that is the flow of, or we can say that bunch of data is going on in the sequence of characters. So for removing this unnecessary headache, we are using here escape bit. So let's understand this example. Our data bit contains data bit as well as flag bit, then our data bit, then our escape bit. So how can we know that in my data bit and escape bit are same in my original data? So for remove that we are using here escape bit. So you can see that when we are sending the data, first we are added flag bit at link clear, then we are using link clear header. Then after we are added here escape bit. Then after my flag bit, then we can see here 2 bits of data. Then if the same data in the form of escape, then another escape bit is added here. So if the data bit and escape bit will be same, then the extra escape bit will be added in our original data part. In the receiver side, if the receiver is found that if extra escape bits are there, then it will remove. So this is the case how in the character oriented protocol we are adding escape bit and removing at the sender and receiver side for removing the confusion between original data bits and pattern bit. So this is all about the byte stuffing. So this is the end of our particular data link layer session. In this particular chapter we learn about these conclusion parts. So first I explained in part number 1 what is the aim of data link layer, what are the services provided by data link layer. In the second we learn about the error detection and correction techniques. Next I discuss about the multiple access layer protocol, and today's video lecture we learn about the addressing techniques and bit and byte stuffing that will be used by our data link layer. So this is all about our data link layer unit conclusion. Thank you for watching this video.